This year we put in the EM304 KONGSBERG multibeam sonar. It's a very exciting addition to the exploration capabilities of Nautilus. I love seafloor mapping because fundamentally we get to explore the unknown, which if you were able to drain the oceans and look at these features, they'd be absolutely astounding. Mapping the ocean is important because it's really the first map that we have of our planet. So it really gives us insights about the geological processes that form and shape the oceans and continue to reshape the oceans. All the terrain of the seafloor provides the habitat structure for all the different things that live in the ocean on the bottom. The first thing you really need when you go to a new place is a great base map of what the terrain looks like, and then from there we can work with the scientists to figure out, okay, what do we want to explore further and in more depth with things like the remotely operated vehicles or other assets that we bring to sea to explore. This year we put in the EM304 KONGSBERG multibeam sonar, which is really a state-of-the-art sonar for mapping deep ocean areas like Nautilus explores. One of the main differences between the two systems is that the 304 has lower frequency capabilities in the outer beams of this swath of sound. In sonars, the lower the frequency, the further it can travel in water. So what they've really done is slightly lower the frequencies in those outer beams. They can go out further in either direction, get echoes back, and you can map a broader swath of terrain as we make a pass with the ship. And so what that really entails is a massive undertaking. We went into a dry dock period, which is getting the ship out of the water, up onto the blocks where we can work on things underneath the ship, pulling out these old transducer elements, putting in new ones into the frame. And then a key element of this is really leveling that whole new sonar array. It's made up of many modules and getting them nearly perfectly flat so they all work in coordination as designed. And then precisely measuring their position in the ship relative to other sensors is essential to having the system work correctly. So we had a professional surveyor working with us on the installation and measuring all these things very precisely. And then basically we're hooking up that transducer system to new electronics, and that whole integrated system is what allows us to map in the deep waters. So pretty much we can map from the edge of the continental shelf all the way down to like the bottom of the deepest trenches with this new sonar. And one of the key capabilities that we're testing is to try a new part of the system where you can actually run a sub-bottom sonar using your multi-beam sonar, which is a very novel thing to do. So it's basically allowing you to look at some of the sub-seabed structure and things like geological sedimentation and layering using your multi-beam system. So it's not just mapping terrain, but it's also can map and give you understanding of what's underneath the seabed in terms of geological structure. This upgrade of the multi-beam sonar was made possible by a partnership with funding from the Office of Naval Research coming through the University of New Hampshire, which has been a key academic partner of the Ocean Exploration Trust, and the manufacturer of the sonar, KONGSBERG, which is a leader in making deep water multi-beam systems. The idea of this multi-beam is really meant to be a deep water test bed for advancing the science of deep water mapping and how do we sort of push the technological limits of what a multi-beam system can do. Bottom line is that mapping in the ocean from a ship can be difficult. A lot of the world's oceans are relatively remote. The deep ocean takes very certain sonars that are able to reach these deep depths to map the terrain. So it's somewhat costly and time intensive, and there's not a lot of ships that are equipped with the right equipment to do it. So Nautilus is one of those vessels that's equipped with the right sonars to map the deep sea. So the multi-beam is sending out essentially a fan-shaped swath of sound as we move along. So each ping is kind of giving you a series of depths across the ocean, and in the deep ocean that can reach as large as 12 kilometers underneath us in a single pass. And as we move along, we keep pinging and we keep getting all those hundreds or sometimes thousands of soundings back. In our case, sometimes you can get in high density mode, you can get up to 1,600 individual soundings of the seafloor, which means as you keep doing that in a row, you're building up pretty much a 3D terrain model of the seafloor beneath us.
We're good. We're good.
Good catch. With this upgrade of our sonar, the main takeaway message is that it allows us to get a much wider swath at any one time. So each pass of the ship, we can map about twice the area in deep water as we were able to before. So as you can tell from that, basically it's making our mapping efficiency much higher. enabling us to map much greater areas with less time. So with resolution, it's really a function largely of the system you're using as well as the depth of the ocean you're working in. So generally speaking, in shallower water, you can map to higher resolution and resolve smaller objects. In the deep sea, like very deep sea, the deepest places we go, we can usually get about 100-meter resolution map, which is orders of magnitude better than what you can get from a satellite system. Expedition 178 is our large transit from Hawaii, where we're doing our current testing cruise, all the way out to Guam, where we're doing work in the Mariana Islands. This transit is all the way across the Western Pacific, and as you might notice if you look at maps of Google Earth or what the coverage of high-quality mapping data is in the Pacific, around the islands we tend to have pretty good data, but as soon as you leave the islands, you tend to get out into the deep waters of the Pacific, which are largely unmapped from ships. Every time we transit across the ocean, we want to do as much mapping as we can and get great data on the seafloor as we make those transits. Another key thing that we're going to be doing on this expedition is doing some new testing. So we're really using this multibeam as a test bed for expanding our understanding of how to push these systems and use them in different ways. This is really what we wanted, is a collaborative environment where the manufacturer of the system, us as a field user and exploration experts, and the University of New Hampshire scientists can collaborate on really pushing the technological boundaries of what's possible with these deep water multibeams.